this is the real Tom Rose, and we're trying to figure out how to minimize the value of a squared plus b squared. Now, it's helpful to notice, first of all, that this number will always be positive, because no matter what you put in for a, it'll be squared and become positive. No matter what you put in for b, it'll be squared and become positive. So all we really care about is the value of the number, not whether it's negative or positive. Now, we're given a constraint. The constraint is the following, that a plus 4 times b minus 4 equals 0. Now, in order to make this 0, one of these two terms must be 0. Either a plus 4 is 0 or b minus 4 is 0. It's the or that's critical to this problem. Now, some people will interpret this to mean that they both must be 0. So let me show what happens if we do that. And this will be a nice baseline for us, actually. If a is negative 4 and b is 4, what we'll find out is this equals 0 because we end up with 0 times 0. So the constraint is held. And in this case, a was negative 4 and b was 4. So the value of a squared plus b squared is negative 4 squared plus 4 squared. And again, we don't care about this negative so much, and you'll see why in a moment. Negative 4 squared is 16, and 4 squared is also 16. So the value we get is 32. Now we do have 32 on our answer choices. And 32 is a possible value, but we've actually been asked to find the smallest possible value. So we can't stop here. We have to ask ourselves, is it possible to make this even smaller? Well, since we want to make this as small as possible, what we want to do is try to figure out how to minimize the value on our input numbers. So we had 4 and 4 here. Again, we don't care about the sign because we're squaring it anyway. So we're trying to figure out how small we can get this number to go. Well, the smallest you could possibly go is 0. So let's take one of these numbers and move it all the way to 0. And it doesn't matter which one we do because the other number, 4, is the value of the other number in both cases. So let's take a and make that 0. And in the case of b, we'll make it 4 again. In this case, we end up with 4 times 0, which equals 0. So we have met the constraint. And when we plug in, we'll end up with, so this was a equals 0, b equals 4. We end up with 0 squared plus 4 squared, which is 16. 0 plus 16, which equals 16. And that is the smallest we can possibly go. How do we know it's the smallest we can possibly go? Well, this one's already down at 0. That can't get any smaller. And this one has to stay at 4 to keep our constraint. If you try any number other than 4, we won't have a 0, which we're required to have. So that's how you know the answer is D.